Hello guys, my name is Bino, and in this video we'll be going through question 3 from the April 7, 2021 N5 Mathematics question paper. Question 3.1, we are given f of x is equals to x cubed minus 7x squared plus 8x plus 3. 3.1.1, determine the coordinates of the turning points of f of x. So to determine the coordinates of the turning point, we simply have to differentiate the f of x and equate it to 0. So the derivative of the f of x, so we differentiate the x cubed, we get 3x squared, and differentiate the negative 7x squared, and we get negative 14x. The derivative of the 8x is equals to positive 8, and the derivative of the 3 is equals to 0. We equate this to 0, so we have 3x squared minus 14x plus 8 is equal to 0. From here, we factorize our equation. The factors of 3x squared, we have 3x and x. The factors of 8, the numbers that we can multiply in order for us to get 8, we have 2 multiplied by 4 is equals to 8, and also 8 multiplied by 1 is equals to 8. So this is it. So to solve this, we have to use the trial and error method. So we take the sign that is here, we put it here, and the sign that we put here multiplied by that sign should be that sign, should give us that positive. So negative multiplied by negative will be equals to positive. So we have the factors of 8, of this 8 as 2 and 4. So we can decide to put the 2 here and the 4 here. If it doesn't work, we will swap them around. So negative 2 multiplied by x is equals to negative 2x. 3x multiplied by negative 4 is equals to negative 12x. Negative 2x minus 12x is equals to negative 14x, and we have negative 14x there as our middle term, so we don't have to go and use that one. So the 2 and 4 are correct. From here we solve for x. We have 3x minus 2 is equals to 0, or x minus 4 is equals to 0. We take the 2 to the right, it's going to change sign from negative to positive 2. And also we take this negative 4 to the right, is going to change sign from negative 4 to positive 4. So we divide both sides by 3. That 3 will cancel out with that 3, and x will be equals to 2 over 3, or x is equals to 4. So far we determined the x coordinates of the turning point. In order for us to determine the y coordinates of the turning point, we have to take these x coordinates and substitute them in the original f of x equation, and not that derived f of x equation. So the original f of x equation, so we substitute. So in order to get the corresponding y coordinate for the 2 over 3, we take the 2 over 3 and we substitute it into that original equation. So where there is x, we put 2 over 3 raised to the power 3 minus 7 into 2 over 3 raised to the power 2 plus 8 multiplied by 2 over 3 plus 3. This will be equals to, so in order for us to get the corresponding y value for this x is equals to 4 coordinate, we take the x coordinate, which is 4, and we substitute it also into the original f of x equation. So when we substitute 4 where there is x raised to the power 3 minus 7 into 4 raised to the power 2 plus 8 multiplied by 4 plus 3, this will be equals to, we have 2 over 3 raised to the power 3 minus 7 multiplied by 2 over 3 squared plus 8 multiplied by 2 over 3 plus 3. This is equals to 5,519 for the other coordinate, which is 4 y is equals to negative 13. So we have when x is 4, y is equals to negative 13, and when x is 2 over 3, y is equals to 5,519. So these are the coordinates of our turning point. 3.1.2, we have to draw up a table of x and f of x where x ranges from x is equals to 0 to x is equals to 5. We have our f of x and our x. From 0, so we have 0, from 0 to 5, 1, 2, 3, 4, and 5. Oh no, these are supposed to be x and f of x. So when x is equals to 0, so when we substitute, so we have our f of x is equals to x cubed minus 7x squared plus 8x plus 3. When we substitute x 0 where there is x, we will get the 3. And we substitute we substitute 1 where there is x. This will be equals to 1. So now where there is x, we put 2. And this will be equals to negative 1. And we substitute 3 where there is x. And this will be equals to negative 19. Substitute 4. We have negative 13, and when x is equals to 5, y is equals to negative 7. Question 3.1.3, draw a neat graph of f of x between the values in question 3.1.2, showing the turning points on it. So we already have our table. So if x is equals to 0, y is equals to 3, so our y is going to be somewhere there. And when x is equals to 1, y is equals to 5. So when x is equals to 1, y is 5 somewhere there. When x is equals to 2, y is negative 1. So negative 1 is going to be somewhere around there. When x is equals to 3, y is equals to negative 9. Or negative 9 is going to be somewhere. Then when x is equals to 14, when x is equals to 4, I mean, y is equals to negative 13. So for 4, we have y as negative 13, and when x is equals to 5, y is equals to negative 7. So for x is equals to 5, y is equals to negative 7. And also our turning points, so we have 4. So we already defined the turning point for a negative 13. The other turning point is 0.662 over 3. 0.66 is going to be around there, and y is going to be 5,519. So 5 is somewhere around there, 5,519 is going to be somewhere there. And from here we draw our graph. And this is going to be our graphs. Let's also define that turning point: 2 over 3 and 5,519. Question 3.1.4. 1 root of the equation x cubed minus 7x squared plus 8x plus 3 is equal to 0 is close to 1,9. Use Taylor's or Newton's method once to determine a better approximation of this root correct to 3 decimal figures. So for this question, we have to use the following formula, which is not available on the formula sheet. So x1 is equal to x0 minus f of x divided by f prime of x. So let's determine our f prime of x. The derivative of x cubed is 3x squared. The derivative of negative 7x squared is equal to negative 14x, and the derivative of 8x is equal to 8, and the derivative of 3 is equal to 0. From here we have to, so this formula was supposed to be x0 minus f of x 0 divided by f prime of x 0. So in the place, so we have to substitute f of x0. So our x0, we are given that it's equals to 1,9. So in the place of x, we'll substitute 1,9. And also we have f of x. So even on our f of x, we also have to substitute the x of 0, which is equals to 1,9. So 1,9 cubed minus 7 multiplied by 1,9 squared plus 8 multiplied by 1,9 plus 3. This will be equals to this is equal to negative 0.77, and for f prime of x, f of x, this is equal to negative 0.211. So we figured out our f of x0 and our f prime of x0, and the x0 was given to us as 1,9. So let's substitute to find x1. So x0 is equal to 1,9 minus f of f0 is negative 0.211 divided by f prime of x0, which is negative 7,7. So a better approximation will be equal to 1,873, and we are told to correct to 3 decimal figures. Question 3.2 states that find the two positive numbers whose product is 750 and for which the sum of one number and 10 times the other number is a minimum. So we have to find the two positive numbers whose product is 750. So let the first number be x and the other number be y. So the product of these two numbers should give us 750. When they talk about product, they talk about multiplication. So when we multiply x by y, we should get 750. And for which the sum of one number, let that number be x, and 10 times the other number. The sum of one number, so when they talk about sum, they talk about addition. So the sum of one number and 10 times the other number, which is y, is a minimum. So we can set this x plus y as any function. So let's choose function f is equals to x plus 10y. When we differentiate, so when they say minimum, it means that when we differentiate f, we should equate it to 0. So when we equate it to 0, we will get our minimum. So we have x, y is equals to 750. Let's make y the subject of the formula by dividing both sides of the equation by x. So that x will cancel out with that x, and y will be equals to 750 divided by x. So in this equation, f is equals to x plus 10y. We equate, where there is y, we equate 750 over x. So where there is y, we substitute 750 divided by x. And this will be equals to x plus 710 multiplied by 750 is equals to 7,500 over the x. So when we differentiate this and equate it to 0, we will get our minimum. But before we can differentiate, let's write that as 7,500 multiplied by x to the power -1. So we take the x from the denominator to the numerator, so the exponent will change sign from +1 to -1. So we differentiate f. The derivative of x is equals to 1. The derivative of 7,500 multiplied by x to the power -1 will be equals to -7,500 multiplied by x to the power -2, and we equate it to 0 so that we can get our minimum. We take this one to the right, it's going to change sign from +1 to -1. From +1 to -1, so we divide both sides by -1, so that we divide both sides by -7,500. So that -7,500 will cancel out with that, so we'll have that x to the power -2 is equals to 1 over 7,500. From here we have to solve for x. We can write this as 1 over x squared so we cross multiply, so x squared will be equals to 7,500. This x squared multiplied by 1 will be x squared. This one multiplied by 7,500 will be equals to 7,500. From here we make x the subject of the formula by introducing the square root both sides. So we were supposed to say to have plus or minus, but they say that these are two positive numbers, so let's only have positive 7,500. So x is equals to the square root of 7,500 is equals to 86,603. To find the value of y, so we have that that y is equals to 750 over x. So where there is x, we substitute 86,603. So 750 divided by 86,603 is equals to 8,66. So x is equals to 86,603 and y is equals to 8,66.